It's fascinating how much thought goes into making things run efficiently, something we often take for granted.
It really is.
Today, we're doing a deep dive into that journey, the evolution of industrial engineering. We'll trace it from, well, the very beginning right up to today's cutting-edge tech.
Exactly. We've got some great material mapping out the key stages. Taylorism, then lean manufacturing, Six Sigma, and now Industry 4.0.
Right. So the mission today is to unpack those core ideas, see how they connect, and, understand their impact.
Let's do it.
Okay, so starting point. Late 19th, early 20th century. Frederick Winslow Taylor and his scientific management. This was a huge shift, wasn't it? Moving away from just relying on experience.
A massive shift. Taylor's whole thing was about applying science to work, replacing those old rule of thumb methods.
How did he do that specifically?
Well, a core principle was the scientific study of tasks, using detailed time studies, literally timing workers, to figure out the single one best way to do a job.
The goal being to cut out any wasted effort, any unnecessary movements.
Precisely. And it wasn't just the what, but the who. Oh. He pushed for scientific selection and training, matching people's abilities to the job.
Like making sure physically strong people did the heavy lifting, and then training them specifically for that task instead of them just figuring it out.
Exactly. Which also meant more cooperation, or maybe more accurately, more supervision from management.
Right. Management's role changed. They became the planners, the instructors, based on the science.
While the workers were the executors. A clear division of work, thinking versus doing.
And this fit perfectly with the rise of mass production, factories churning things out, increased productivity, lower costs.
Absolutely. Its influence was huge. We still see echoes in org charts, performance reviews, that kind of thing.
But it wasn't all positive, was it? There were definitely criticism.
Oh, for sure. A big one was the dehumanizing aspect. Workers doing repetitive, highly specialized tasks over and over. Critics said it stifled initiative.
And unions weren't happy either.
No, they had concerns about workload increases without fair reward. It highlighted that classic tension, efficiency versus the worker's experience.
Okay, so moving forward from Taylorism, we get lean manufacturing. This seems broader, looking beyond just one task.
Yeah, much broader. Lean focuses on the entire production system and critically on what the customer actually values.
So defining value first, from the customer's viewpoint function, price, timing.
Exactly. Then you map the value stream, all the steps involved, and ruthlessly hunt down waste, the famous 7 wastes.
Like making too much stuff, waiting times, unnecessary transport, overprocessing.
Inventory, motion, defects, all of it. The idea is to make value flow smoothly without interruption.
Which requires different departments working together, I imagine.
Definitely. And it leads to the pull concept, making things only when the customer actually needs them just in time.
Minimizing that wasteful inventory. Plus the whole perfection idea, continuous improvement or Kaizen, getting everyone involved.
It really emerged strongly in Japan, post-World War II. Toyota, specifically, they had limited resources, so they had to be flexible and incredibly efficient.
The Toyota production system. Figures like Taiichi Ohno.
Right. It was a much more holistic, maybe more human-centered approach than strict Taylorism. It looked at the whole flow, not just isolated movements.
Okay, then comes Six Sigma. This sounds very statistical, focused on quality, right?
Very much so. The big headline is quality and reducing variation, that famous goal. 3.4 defects per million opportunities. It's incredibly ambitious.
Wow. And it uses a specific framework.
Yes, the DMAIC framework. Define, measure, analyze, improve, control. It's a very structured, data-heavy way to solve problems and reduce those defects.
So lots of statistical analysis.
Absolutely. It's all about understanding the process, finding root causes of variation, and controlling it. Customer satisfaction is key, and it often involves cross-functional teams.
Yeah, the whole belt certification thing. Black belts, green belts.
Right, structured training. It started at Motorola back in the 80s, but really took off when Jack Welch championed it at GE.
So compared to Taylor's time studies or Lean's waste focus, Six Sigma brings this intense analytical rigor specifically to quality and consistency.
Exactly. You can see how they complement each other. Lean clears out the obvious waste. Six Sigma tackles the finer points of variation and quality. That's why you often hear about Lean Six Sigma now.
Which takes us to, well, today. Industry 4.0. This feels like a whole different ballgame. Digital transformation.
It really is a paradigm shift. We're talking about integrating intelligent digital technologies into manufacturing and beyond. Smart factories, basically.
Driven by things like What is
Internet.
the Internet of Things?
The industrial Internet of Things, yeah.
Yeah.
IIoT, billions of sensors and devices all connected, sending data. Then you have AI and machine learning making sense of it all, enabling smarter decisions.
Big data analytics, advanced robotics, cloud computing.
Cyber-physical systems, linking the physical world to the digital for real-time control. Even additive manufacturing, like 3D printing for complex parts or customization.
The potential seems enormous. Self-optimizing production lines, predicting machine failures before they happen.
Enhanced quality control using sensors and AI, mass customization, optimizing entire supply chains, even improving worker safety with collaborative robots or cobots.
So the job of an industrial engineer must be changing dramatically.
Completely. Skills in data analytics, IoT, AI, cybersecurity, systems integration are becoming essential. It's much more interdisciplinary.
Benefits are clear. Efficiency, cost savings, quality boosts, speed, but there must be hurdles.
Definitely. The upfront investment is significant. Integrating all this tech is complex. There's shortage of skilled workers. Cybersecurity is a huge concern.
Data overload too, maybe, and potential job displacement, cultural changes within companies.
All valid challenges. But we see companies like Siemens, Harley-Davidson pushing forward and getting real benefits. It's happening.
What an incredible evolution. From timing simple hand movements with a stopwatch to designing these interconnected, intelligent, almost autonomous systems.
It really puts it in perspective.
It makes you wonder. These core ideas we've traced, analyzing scientifically, cutting waste, striving for quality, now leveraging digital power, they all still seem relevant, don't they? Building on each other.
Absolutely. The foundations are still there.
And maybe they point towards what's next. People talk about Industry 5.0, focusing more on that human-machine collaboration, sustainability. So thinking about this whole journey, which stages principles do you think resonate most powerfully for how we'll work and create things in the future? Something for our listeners to chew on.